Question 1. Work out 6.84 divided by 0.12. I want to get rid of these decimals, and we can think of a division the same way we think of a fraction. So whatever we do to the top, we can do the same to the bottom. And to get rid of the decimals, we can times the top by 100 and the bottom by 100. And I'll use long or short division to work this out now. I'll write the 12 times table down the side, just because it might help out. And how many 12s go into 6? That's none. How many 12s go into 68? That's 5, which makes 60. So there's 8 left over. How many 12s go into 84? That's 7. So the answer is 57. Question 2. A plane travels at a speed of 298 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. So it goes 300. So we're rounding. We're going to say 298. We're going to round it to the nearest 100, which makes it 300. 300 miles in 1 hour, which is 60 minutes. If we divide by 60, we can work out how far it goes in 1 minute. So 60 goes into 300 5 times. So it goes 5 miles in every minute. So that's 5 miles in 60 seconds. So divide by 5. That makes it 1 mile in 60 divided by 5 is 12 seconds. Is your answer to part A an underestimate or an overestimate? Give a reason for your answer. So the actual speed is lower because we rounded it up. So the actual speed is lower. And if it's slower, it will take longer to travel a mile. So the slower the speed, the longer it takes to travel a mile. So it will actually be an underestimate. The plane is actually slower. Therefore, the time is longer. Question 3. Simon writes down 3 numbers, A, B, and C. We've got a ratio of A to B, 2 to 3. The ratio of B to C is 5 to 4. We want the ratio of A to B to C. So in these questions, we've got a B in both. We need the B's to be the same. How can we make them the same? We've got a 3 and a 5. If we times the first one by 5 and the second one by 3, the B's will both be 15. So the ratio of A to B, instead of 2 to 3, I'm going to times them by 5. I'm going to say it's 10 to 15. So it's the same ratio as 2 to 3. It's equivalent. And B to C, we're timesing by 3. So it's 15 to 12. So we've got a ratio A to B to C. We can put them together because the B is the same. So A to B to C is 10 to 15 to 12. Alvin writes down 3 numbers, D, E, and F. D equals 3 E's, E equals 4 F's. Find the ratio D to F. So when E is 1, if E is 1, D is 3. And when F is 1, E is 4. So now we can change these into ratios. The ratio of D to E is 3 to 1. And the ratio e to f is 4:1. We need to make the e's the same. So if we times the first one by 4, it's 12:4. So d to e to f, d to e to f is 12:4:1, which makes d to f just 12:1. Question 4, work out 2 3/4 plus 3 1/3. Give your answer as a mixed number. So we're going to change these fractions into top-heavy fractions. So 2 whole ones, 2 times 4 is 8/4. 8/4 and 3/4 make 11/4. 3 threes are 9, so 3 whole ones is 9/3 plus another third, that's 10/3. We need the bottom numbers, the denominators, to be the same in order to add the fractions. So I'm going to times the second one by 4, the first one by 3, and that will make both the denominators 12. That's 33/12 plus 40/12. Add them together, we get 73/12. We want a mixed number. So how many 12s go into 72? 12 times 6 is 72. So that's 6 whole ones and 1 12. Show that 1 3/5 divided by 6 equals 4/15. So I'm going to change 6 into 6/1. I'm going to make it into a fraction. And I'm going to change 1 3/5. 1 whole one is 5/5. So I'm going to change that into 8/5. I'm going to write 8/5 divided by 6/1. When we divide fractions, we can change it to a times by flipping over the second fraction. So dividing by 6 is the same as timesing by 1/6. And I'm just going to times the top, times the bottom. So 1 times 8 is 8. 5 times 6 is 30. And then we just need to half the top, half the bottom, and we get to 4/15. Question 5. A large box exerts a force of 900 newtons on the ground. That's the force. The force is 900 newtons. The base of the box in contact with the ground is a 3 by 2 meter rectangle. So what's the area in contact with the ground? Area is 3 times 2, so 6 meters squared. So that is the area. So we need to work out the pressure. It's just force divided by area. So 900 divided by 6. So we can go straight into 900 divided by 6, or we can half them first. 450 over 3. How many 3's go into 450? Or 3 times what number is 450? It's 150. So it's 150 newtons per meter squared. Here is a rectangle. All measurements are in centimeters. The area is 36 centimeters squared. Find the value of y. When we have a rectangle, we know the two opposite sides have to be equal. So we can make an equation. 5x minus 7 must be equal to 2x plus 8. And then we can solve this equation to find the length of the rectangle. So take away 2x from both sides. We're going to take away the smallest x, which is the 2x. So that will become 3x minus 7 equals 8. We want the x by itself. So let's get rid of this minus 7. The opposite of taking away 7 is adding 7. So 3x equals 15. Then divide both sides by 3. X is 5. If x is 5, what is the length? So 2 5s plus 8 makes 18 centimeters. And the same should work for the other one. So 5 5s, 25, take away 7 is also 18. So it's 18 times y is the area, and that equals 36. So 18 times y equals 36. Y must be 2. Question 7. Larry has 9 boxes. The mean weight of the 9 boxes is 1.5 kilograms. This is going to be a reverse mean question, and we can undo the mean by multiplying. So we've got 9 boxes with a mean weight of 1.5 kilograms. So we can work out the total weight by doing 9 times 1.5. So a 9 plus half a 9, 9 plus 4.5 is 13.5 kilograms. That's the total weight of all the boxes. The mean weight of 4 of the boxes is 2 kilograms. So 4 times 2 is 8 kilograms. So 9 boxes weigh 13.5. 4 of them weigh 8. What's the mean of the other 5? So to find the weight of the other 5, we do 13.5, take away 8, and that will give us 5.5 kilograms. So that's 5 boxes, weigh 5.5 kilograms. What's the mean? 5.5 divided by 5, it is 1.1 kilograms. Question 8, solve the simultaneous equations. To solve these, we're going to use elimination, and we're going to need to make the x's the same or the y's the same. I'm going to make the x's the same by timesing the bottom one by 3, and I'm going to leave the top one as it is. So we've got 6x minus 5y equals 11. That's unchanged. The bottom one times 3 will be 6x minus 9y equals 27. So now we have the x is the same. We can eliminate x. So if we do 6x, take away 6x, it will disappear. There'll be no x's left. So I'm going to take away one equation from the other. 6x take away 6x is nothing. Negative 5y minus 9y. So negative 5y plus 9y is 4y. And 11 take away 27 will be negative 16. So y is going to be negative 4. I can substitute that back in now to find x into either the first one or the second one. It doesn't make a difference. I'll do the top one. So 6x minus 5 times negative 4, so changing y, equals 11. Negative 5 times negative 4 is a positive 20. So 6x plus 20 equals 11. Take away 20 from both sides. That's negative 9. And then divide by 6. X is negative 9 over 6, or negative 3 over 2, or negative 1.5. So x is negative 1.5, and y is negative 4. Question 9, part A. Work out 16 to the power of a half. Take away 27 to the power of 1/3. The power of a half means square root, and the power of a third means cube root. Square root 16 is 4, because 4 times 4 is 16. And the cube root of 27 is 3, because 3 times 3 times 3, 3 cubed, is 27. So we've got 4 take away 3. The answer is 1. Part B, simplify square root 27 plus square root 48. When we're simplifying surds, we're looking for a square number inside the surd, and square root 27 is 3 nines. So root 9 times root 3. And root 9 can be changed into a normal 3. So square root 27 is the same as 3 root 3's. Square root 48 is 16 times 3. Root 16 is 4, so it's 4 root 3's. And we've got 3 root 3's plus 4 root 3's. So in total, we've got 7 root 3's. Question 10. Write these numbers in order of size. Start with the smallest number. So we have a kind of standard form type question. We need to put these numbers as, let's write them all as ordinary numbers, and then we'll just be able to compare them. So 0.372 times 10 3 times. So 1, 2, 3, that would be 372. 3,720 times 10 to the power of negative 2 means 3,720 divided by 10 twice. That would be 37.2. 372 times 10 twice will be 37,200. And 0.00372 times 10 6 times 3,720. So in order of size, the smallest one is 37.2, then 372, 3,720, and then 37,200. I'll just write these out. And that is our answer. The table shows some information about the profit made each day at a cricket club on 100 days. Complete the cumulative frequency table. Cumulative frequency just means we're adding up as we go along. So 0 to 50 is 10 people. 0 to 100 is 0 to 50 plus 50 to 100. So 25. 0 to 150 is the first 3 added together. So plus on the 25. 0 to 200, add on 30, and then add on 5, and then altogether there are 100. Everyone is in 0 to 300. And we need to draw a cumulative frequency graph for this information. So with a cumulative frequency graph, we're plotting the top point, the 50, against 10, 100 against 25. So 50, 10, 125. And it's 50, 80, 85, 100. So 50, 80, 85, 100. And we can join these up with either a smooth curve or straight lines. I'm going to use a ruler, straight lines, because the smooth curve is very difficult on the computer. So that is our cumulative frequency diagram. Use your graph to find an estimate for the number of days the profit was less than £125. So let's find £125, which is here. And we're somewhere here. So we read off the graph. And it looks like we're at 37. So how many days less than 125? 37 days. Use your graph to find an estimate for the interquartile range. So we're going to split the data into quarters. So halfway, the median is 50. Half of that is 25. So the lower quartile, we're going to go to 25, along to the line and down. So the lower quartile is at 100. The upper quartile, we want 75, along to the line and down. So somewhere in there. So let's read that off. Where is that? So that's 60, 160, 170, 180, 190. So between 190 and 195, 192 or 192 and a half. So the upper quartile, take away the lower quartile, is the interquartile range. So let's say 92. Question 12. The equation of L1 is y equals 2x plus 5. The equation of L2 is 6y plus kx plus 10 equals 0. The two lines are perpendicular. Find the value of k. So if the gradient of L1 is 2, so it's y equals mx plus c. M is the gradient, c is the y-intercept. So the gradient of the first line is 2. So the perpendicular gradient is a negative reciprocal, so minus a half. The gradient of L2 has to be minus a half. So if we put it into the form y equals mx plus c, and then work out what k has to be for the gradient to be minus a half. So let's take away kx from both sides and take away 10, and then divide everything by 6. And see what we've got. So the gradient is minus k over 6, and it has to equal minus a half. So k will be 3. Question 13. The diagram shows a hemisphere with a diameter of 6 centimeters. If the diameter is 6, that means the radius is 3. Work out the volume of the hemisphere. So the volume of a whole sphere is 4/3 pi r cubed. So the volume of half of that is just half. So 2/3 times pi times the radius cubed. So we've got 3 cubed, which is 27. So 2/3 of 27 pi. 2/3 of 27. So 1/3 of 27 is 9. 2 9s make 18. So we've got 18 pi. Question 14. Y is directly proportional to root x. So we can write that as a formula. If it's directly proportional, it's k times root x, where k is just a number that we can work out. So if it's directly proportional, y equals k times root x. If it was inversely proportional, it would be k divided by root x. That's for a different question, not for this one. So y equals k times root x. When y is 9, x is 4. So root 4 is 2. 9 equals 2 times k. So k is 9 divided by 2, or 4.5. So we've worked out what k is. That means we now have the formula y equals 4.5 times square root x. Find the value of y when x is 16. So just substitute 16 in. 4.5 times square root 16. Square root 16 is 4. So 4.5 fours. Double 4.5 is 9. Double 9 again, 18. Question 15. Prove that 3n plus 1 squared, take away 3n minus 1, all squared, is always a multiple of 12 for all positive integer values of n. So all we have to do is expand and simplify, and we should be left with something that's clearly a multiple of 12. So we're going to expand 3n plus 1 times 3n plus 1, and 3n minus 1 times 3n minus 1. We have to be careful with this minus sign because we want to take away all of this expansion, not just the first term. So 3n times 3n, 9n squared. 3n times 1 is 3n. 1 3n is 3n, and 1 1 is 1. I'm going to keep this bracket around the second expansion because I know I want to take away all of it. 3n times 3n, 9n squared. 3n times negative 1 minus 3n, minus 1 times 3n is minus 3n again. And negative times a negative makes a positive. So negative 1 times negative 1 is positive 1. I will collect the like terms. So 3n and 3n make 6n. And minus 3n minus 3n is minus 6n. I'm going to take away all of this second bracket. I'm just going to write it out first. So it's like expanding a bracket with a minus 1 here. All the positives will become negative. All the negatives will become positive. So we're going to get minus 9n squared plus 6n minus 1. And then we've got 9n squared take away 9n squared, which is nothing. 6n plus 6n is 12n. And 1 take away 1 is nothing. So it's 12 times n. It's clearly a multiple of 12. Question 16. There are 10 counters in a bag, 5 red, 3 blue, 2 green. Billy takes 2 counters. Billy takes 2 counters at random from the bag. Work out the probability that both of the counters Billy takes are the same color. You must show your working. So we could draw out a probability tree for this. I'm not going to. I'm going to say the probability of getting 2 red counters, probability of red, red, is the probability of the first one being red. So there are 5 red out of 10 in total, times the probability of the second one being red, if the first one was red. So if the first one's red, there's only 4 left that are red out of 9 in total. So 5 times 4 is 20, 10 times 9 is 90. The probability of 2 blues, blue then blue. The first one is 3 tenths. And then if we took a blue one, there'll be 2 left out of 9. So the probability of the second one being blue is 2 over 9. So the probability of blue, blue is 6 over 90. And for green, green, it's 2 tenths times 1/9, which is 2/90. So what is the probability that both of the counters are the same color? It can either be red, red, or blue, blue, or green, green. So add them all together. That makes 28 out of 90. 28 out of 90. F of x is 3x minus 4 over 2. Find the inverse function, f minus 1x, the inverse function of f. So the opposite of f, you can think of this as a function machine. If you start with x, what do you do with it? So you go in, you would times it by 3, then take away 4, and then divide by 2. And you would get your output. If you went backwards, the inverse function is the backwards function of this. So if we started with x, the opposite of dividing by 2, which would be times it by 2, the opposite of taking away 4 is plusing 4, and then the opposite of timesing by 3 is dividing by 3. So that is the inverse function. It's the thing that does the opposite. For all values of x, we've got g of x is x squared plus 3x. H of x is 3 minus 2x. What is g h of 4? So with these composite functions, we start with the right side. We're going to put 4 into h, and then we're going to put that answer into g. So h of 4, 4 into h, 3 minus 2 4s. So we're just changing x into 4. 3 minus 8 is negative 5. Now let's put negative 5 into g. G of negative 5 squared plus 3 negative 5s, 25, take away 15, 10. So GH of 4 is 10. Question 18. Triangle A is transformed by the combined transformation of a reflection in the x-axis. Let's do that first. Reflect in the x-axis. So there's our mirror line. It's 3 tool. So reflection in the x-axis, followed by a reflection in the line x equals negative 2. That's here. So there's our triangle. And then it's followed by a translation with vector negative 4, 2. So that means 4 left, 2 up. So let's take this triangle, move it 4 to the left, 1, 2, 3, 4, and then 2 up. So we will have the triangle over here. 1 point on triangle A is invariant, so it doesn't move. Under the combined transformation, find the coordinates of this point. So it's going to have to be this point at negative 4, 1. So let's just check it is in the same place. So it reflected to here, then to here, and then move 1, 2, 3, 4, 1, 2, and it's back to where it started. So it's negative 4, 1. Question 19. Find the coordinates of the turning point on the curve with equation y equals x squared plus 8x plus 11. You must show you're working. To find the turning point of a quadratic, we can complete the square. So we're going to be halving our b, halving the middle number. Half of 8 is 4. So we're going to have x plus 4 squared. Then we're going to take away 4 squared, which is 16, and we're still going to have the plus 11 here. The reason we've done that is if we had x plus 4 squared, that's x plus 4 times x plus 4, that's x times x is x squared, plus 4x plus 4x plus 16. So x squared plus 8x plus 16. So we wanted x squared plus 8x, but we didn't want the 16. So we take away the 16. So this part here is the same as x squared plus 8x, because it's x squared plus 8x plus 16 minus 16. So it's just rewriting the same equation in a different way. And simplifying, we've got x plus 4 squared minus 5. So x plus 4 squared minus 5 is the same as x squared plus 8x plus 11. But the good thing about it is we can use this to work out the turning point. So the smallest thing we can possibly get is when this bracket is equal to 0. That's when x is negative 4. And when x is negative 4, y is negative 5. So our turning point is at negative 4, negative 5. Question 20. A, B, and C are three spheres. The surface area of sphere A is 25 centimeters squared. The surface area of sphere B is 36 centimeters squared. The ratio of the radius of B to the radius of C is 2 to 3. Work out the ratio of the volume of sphere A to the volume of sphere C. So when we've got similar shapes and area and volume and length, the scale factor for length is the scale factor. If we have area, the scale factor for area is the scale factor squared, and the scale factor for volume is the scale factor cubed. You can imagine if you had a cube or two cubes. One's 1 by 1 by 1, one's 2 by 2 by 2. So for the length, it's times 2. For the area of a face, so the area of the front is 1 times 1, which is 1 for the small one, and 2 times 2, which is 4 for the big one. So it's times 2 squared. And the volume of the small one is 1. The big one is 2 times 2 times 2, which is 8. So the scale factor for volume is the scale factor cubed. So we're going to use that in this question. So we've got the scale factor for area of A to B, which is a ratio of 25 to 36. So for length, we want to square root. To go back from area to length, we square root. So the scale factor is 5 to 6 for lengths. And we know for B to C, for lengths, it's 2 to 3. So if we want A to C, we're going to have to make the B's the same, times by 3, 6 to 9. So we have, for lengths, A to B to C is 5 to 6 to 9. We want A to C. So for lengths, A to C is 5 to 9. For volume, we're going to cube the scale factor, so it's going to be 5 cubed to 9 cubed. 5 cubed is 5 times 5 times 5, 125. 9 cubed is 9 times 9 times 9. So we've got 9 times 9 is 81. 81 times 9 is 729. So it's 125 to 729. Question 21. A and C are points on a circle, centre O. A, B and BC are tangents. Prove that ABO, so this triangle, is congruent to BCO, to the other triangle. We can do this lots of ways. So we can do 3 lengths. We can say O to A and O to C are both radius. We can say that OB is common to both, so therefore the same. And we can say that 2 tangents from the same point, AB and BC, 2 tangents from the same point are equal. So to have congruent triangles, we can say we've got side, 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 therefore congruent. We could have also done this by saying we've got a right angle, tangent meets a radius at 90 degrees, and then we could have had right angle hypotenuse on one other side, or side angle side. Any of those would have been okay. So to be congruent, we can have side, angle, all 3 sides, or the right angle, the hypotenuse, and one other side. It doesn't matter which one we get to, as long as we get to one of them, we have proved that the 2 triangles are congruent. Question 22. N is an integer such that 6n minus 10 is greater than or equal to 8, and 2n squared is less than 13n take away 6. Find all the possible values of n. So we've got 2 inequalities that we need to solve. Let's start with the straight line one, the linear one. Plus 10 to both sides. 6n is greater than or equal to 18. Divide both sides by 3. N is greater than or equal to 3. For the quadratic one, let's make it equal to 0. So minus 13n and plus 6 to both sides. Then we can factorize. There are different ways of factorizing these quadratics with a coefficient of x squared or n squared greater than 1. I'm going to go straight to the answer because I know it's going to be 6 and 1 to give me my 13, because 2 6s make 12. 12 and 1 make 13, and they're both negative. So we have n is a half to make this bracket 0, and n is negative, n is positive, n is 6 to make the second bracket 0. Where is this less than 0? If you imagine the graph like this, where is it less than 0? It's less than 0 down here, where it's under the axis. That's where it's less than 0. So that will be in between a half and 6. So it's n is bigger than a half and less than 6. So they've both got to be true. What can n be? So it's got to be bigger than 3, and it's got to be in between a half and 6. So 3, 4, and 5 are the possible values that work. It can't be 6. and it can't be anything bigger than 6, but it's got to be bigger than or equal to 3, so 3, 4, and 5. And last question, DEF is a triangle. P is the point on F to D, such that F to P is 3 parts and P to D is 1 part. Q is the point on FE. F to Q is 1 part, Q to E is 2 parts. The whole of F to D is called 6A. The whole of F to E is 6B. So F to P is 3 quarters. So there are 4 parts. F to P is 3 of them. 3 quarters of 6A. So put 4.5A. And P to D is 1 quarter. A quarter of 6 is 1.5. F to Q is a third. So that's 2 B's. And Q to E is 2/3, 6 B's. Use a vector method to find Q to R. So Q to R in terms of A and B. So we're going to have to go 2 different ways to get from Q to R. We can say it's a fraction of Q to D. So it's some fraction of Q to D. It's some fraction of this journey Q to D. Or we could go along here to E and then say it's some fraction of that journey from E to P. And we don't know what those fractions are, but we'll be able to work that out using simultaneous equations. So let's go from Q to D first. That seems quite easy. So from Q to D, we're going to go minus 2B and then 6A. So Q to R is just some fraction of this. I'm going to call that fraction X. Some fraction of that journey. And then I'm going to go from E to P. How can I get from E to P? I have to go the long way. So minus 6B and 4.5A. So we're going to say that E to P is minus 6B plus 4.5 A's. And E to R is some fraction of that journey. I've used X, I'll use Y. So E to R is some fraction of that. So Q to R will be 4B plus E to R. So Q to R is 4B plus Y times minus 6B plus 4.5 A's. So I've gone from Q to R in 2 different ways. Q to R by going along each of the 2 different lines, and they must be equal. So these 2 must be equal. So X times minus 2B plus 6A must be equal to 4B plus Y times minus 6B plus 4.5A. I want to separate my A's and B's. I'm going to expand the brackets first. So I'm going to say I've got minus 2xb plus 2xa equals 4b minus 6yb plus 4.5ya. So in order for these to be equal, the a's have to be equal. So the a's on the left have to equal the a's on the right. and the b's on the left must equal the b's on the right. So the a's equal the a's, and the b's equal the b's. So 6x must be the same as 4.5y, and minus 2x must be equal to 4 minus 6y. So now I've got a simultaneous equation that I can use to solve this. And if I just find out what x is, not y, I'm going to find out what x is and just substitute it in to my q to r. So I'm going to get rid of y. So if I divide 6 by 4.5, 6 over 4.5 x, 6 over 4.5, divide top and bottom by 1.5, that's 4/3. So y is 4/3 of x. I'm going to substitute that in. So I've got minus 2x equals 4 minus 6 times 4/3 of x. 6 times 4/3, so 6 fours are 24, over 3 is 8. So I've got minus 2x equals 4 minus 8x plus 8x to both sides, and divide by 6. 4 over 6 is the same as 2 over 3. So x is 2/3. I'm just going to substitute that in for x in my q to r. So q to r is 2/3 times minus 2b plus 6a. So there is q to r in terms of a and b. I'll expand the brackets. So 2/3 times negative 2 is negative 4/3. 2/3 of 6 is 4. So I've got 4a minus 4/3 of b.